For that, during its building, provisional floating tanks were made available, which made it possible for the floodgate to float horizontally. Floating vertically, they didn't pass through the old lock due to its lesser depth. This stage was especially difficult as in the riverside floodgates there only existed a 1.5 centimetre margin on either side. Once they arrived at the new lock, they were placed vertically with the help of a 750-ton crawler crane, executing by means of a system of pulleys and returns the manoeuvre of entrance into the garages. Afterwards, the floodgates were placed in a position of maintenance to proceed with putting all the pulley elements in place, assembly of upper and lower carts, installation tests, etc. As with the floodgates, the bridges were also built while the work was carried out, so that they would be ready on finalizing the structure of the lock. They were built by segments in factories outside the work and later assembled there in especially built platforms. Later, and with the same crane used for the floodgates, the decks were cast from the south side of the lock. The counterweights were placed over the piers, and these were anchored to the decks with tie bars. Similarly, once the building of the lock was quite complete, the construction of the building complex in the built-up area began, with the purpose that it would be finished when the bridges and floodgates were operating. While these functions were being carried out, and others such as the layout of roadways and railways, the fluvial traffic continued its previous course. Coinciding with the building of the structure, the preparation of the areas before and after the lock in the navigation canal began, consisting in a dredging of the complete section of the riverbed down to the levels -9.5 and -7.7 metres respectively, and protecting the river banks with rip-rap. For the dredging, a cutter suction dredger was used, capable of reaching depths of 18 metres and pushing the mixture, water, soil in suspension, extracted from the riverbed more than 2 kilometres in distance, with the object of sending it to a decanting enclosure. Once the area was flooded and the accesses to the new lock dredged, the maritime traffic was transferred there, although it still wasn't operative, to begin filling the present navigation canal and re-establish the new flood defences before being put into operation, cancelling the previous lock. The most significant sizes of the work have been 4 million cubic metres of dredging, 1,700,000 cubic metres of excavation, 2,800,000 cubic metres of earthfill, 54,000 square metres of plastic wall, 5,000 tons of steel for sheet piles, 300,000 cubic metres of concrete, 100,000 square metres of formwork, 20,000 tons of corrugated steel, 5,200 tons of steel in bridges, 3,250 tons of steel in floodgates, 2,090,000 square metres of operating areas. The construction of the new port of Seville lock means a wager for the sustainable development of the very city of Seville. On facilitating the entrance of larger ships with the new access, the competitiveness of the port installations is definitively improved. Located downwater from the previous lock, 120 hectares of land have been gained, which won't be flooded yet, for port activities, new offices and industrial buildings. The new port of Seville lock is established, consequently as one of the gates of its future, allowing the entrance of giant cargo ships and tourist cruisers up to the centre of the city, and converting Seville in a reference point for maritime transport between Spain and the rest of the world. And all this thanks to the unbeatable human, material and technological capacities of FCC Construction, always in the vanguard of the great works of engineering.
Seville.